A mining company has two sources of gold ore, mine A and mine B. 2 grams of gold can be extracted from each ton of ore from mine A. 3 grams of gold can be extracted from each ton of ore from mine B. Ore from both sources is processed at a single processing plant. In order to keep the plant running, a total of at least 3 tons of ore must be processed each hour. Staffing constraints at the mines determine that the amount of ore processed from mine B cannot exceed twice the amount of ore processed from mine A. Ore from mine A costs $20 per ton to process, and ore from mine B costs $10 per ton to process. Processing costs must be kept to no more than $80 per hour. So we're going to let X be the number of tons of ore per hour processed from mine A, and Y be the number of tons of ore per hour processed from mine B. The following 4 constraints can be obtained from the information above. Well, these are the non-negativity ones, so we don't need to look too closely at those. And then we're going to just quickly look at these ones. This one here appears to be from the information in this paragraph here to do with costs. So this one is to do with costs. And x plus y is greater than or equal to 3 appears to be this paragraph here, where we have to have a total of at least 3 tons of ore. So this one is the process. So state the final constraint that applies to the situation. That seems that it must come from the final paragraph just here. So staffing constraints at the mines determine that the amount of ore processed from mine B cannot exceed twice the amount of ore processed from mine A. So if those were actually equal, that would be y equals 2x, but we're told that it can't exceed, so that must be a less than or equal to. So our final constraint is y is less than or equal to 2x. We now want to draw all of the constraints on the axes below and indicate the feasible region. So we know that we need to be this side of the y-axis and this side of the x-axis. The bounding line here is x plus y equals 3. So let's draw that one on. X plus y equals 3 would be here. We should label it really. So x plus y equals 3. And that's a greater than or equal to, so we need to be this side. This one here we could reduce to 2x plus y is equal to 8. So if y is 0, x would be 4. If x is 0, y would be 8. So that's going to be this line just here. Let's label it 2x plus y equals 8. And that's a less than or equal to, so we're going to need to be this side of that one. And then y equals 2x. So, for example, when x is 4, y would be 8. So that's going to be about here. And so that's y equals 2x. And that's a less than or equal to, so we need to be this side. This is where y is less than 2x. So the region that fits all of those is this region just here. The company wants to maximize the total weight of gold extracted. How many tons of ore from each mine should be processed each hour? So looking at the information here, the weight is going to be 2x plus 3y. So we want to maximize that in this region, so we need to look at the vertices. So vertex and weight. So we can see that 3, 0 is a vertex, and so is 4, 0. This vertex here is the intersection between y equals 2x and 2x plus y equals 8. So substituting in 2x plus 2x equals 8, 4x equals 8. So x is 2 and y would then be 4. And finally this one here is the intersection between x plus y equals 3 and y equals 2x. So that would give us 3x equals 3, so x equals 1 and y equals 2. So this would be 6, this would be 8, this is going to be 4 plus 12, which is 16, and this will be 2 plus 6, which is 8, and so this is the best. So we want 2 tons from A and 4 tons from B. A new technique enables K grams of gold to be extracted from each ton of ore from mine A, where K is greater than 2. What is the smallest value of K that would enable the maximum weight of gold to be extracted without processing any ore from mine B? So the new weight function would be Kx plus 3y. There's no change to what happens from mine B. If we don't want to process anything from B, that means switching to the vertex just here at 4, 0. So we want W at 4, 0 to be equal to W at 2, 4. So substituting in, that's going to give us 4k plus 0, so just 4k, equals 2k plus 3 times 4, which is 12. So that gives us 2k equals 12, and therefore k is equal to 6.